one. Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have one of our students that has completed her ROS Basics course, and at the end of the course, she has to complete a project in which she has to implement it in a real robot. So she's going to be showing us what she did with her project. Her name is Claire. Hi, how are you, Claire?
I'm fine, thanks. What about you?
I'm doing really well. Excited to see what you've done with your project. So without further ado, whenever you want, you can start sharing your screen and you're just telling us what you've done.
Okay. So, first of all, can you see my screen correctly?
Yes, I can see it. We can
Yeah.
see the robot now in a terminal.
Okay, perfect. So we try just to, we put the terminal like that to try to give you a both view, but unfortunately, so
This looks good.
like,
Yeah.
okay. So I will run, I will say my project and hope everything will be all right.
Yeah, let's look at it. Let's see.
So yeah.
Oh,
So
so
the
we see
first,
the, yeah,
yeah.
go ahead.
So the first part of that project was the robot to find the wall. So it was he's doing here. And after normally the robot will just follow the wall. So it will complete a lap
Mm-hmm.
and stop at the end of the lap, normally almost at the same point, I would say, than where it starts,
All right.
basically.
Okay.
So here I have, I would say, due to my connection and due to, I would say, the angles and the speed of the robot, you can see that the robot move a bit around, I would say, a mean position.
Uh-huh. So it's like swinging around.
Yeah, it swing a
Yeah.
bit around, unfortunately. But yeah.
No, but it's doing it really well. I mean, it's going, and then you said it will stop after completing a lap?
Normally, yes, and you will see all the record, I will say, with the odometry
Mm-hmm.
for the position and yeah, I will say, yeah, and normally you will have the total length of the lap as well.
Okay,
So
yeah.
you can see here we have a feedback, and we also receive what the robot can see, and normally up, of course. And the robot didn't stop because the length, I would say, between the initial position and I would say the distance between the initial position and the current position was
Was
not in
not
the
close
gap.
enough.
Yeah, it was not close enough. This happens sometimes. So we carry on to do loop until I will say it will find that basically.
I see. I see. Uh, all right. Okay, that's fine.
That's fine. Yeah.
Why don't you just leave it running while you explain how you solve
Yeah.
this? You know, maybe it'll
Unf-
find it.
Unfortunately, since I say it's yeah. So what I did to solve that. So first of all, I will explain to find the wall. So to find the wall, basically it was you needed to rotate the robot. So in my case, I say to the robot, if if you find an object regarding a certain distance, so in that case, it was 0.4 regarding the real robot. So
Uh-huh.
um, at that moment, you need to stop. I say any crash because, of course, due to the gap. So yeah, I will go here. So you can see here I use, I will say, the front laser in that case. So the front reading of the laser, because the laser it's 719 degree because you have a step of 0.5 degree all the time. So you move, you do 0 degree, 0.5, etc. So
Mm-hmm.
I used the 360. I didn't use the minimum because in my case with the real robot, I noticed that the minimum was not really working. So at the moment I decided to use not an easy solution, but something that was working in the real case. So the front laser in that case,
Mm-hmm.
that I'm sure that I can control it at the same time. So I decided to say, so I put a while because it's a server. So when you call the server, you call only one time because you send a request. So at that moment, if you don't block it in a while and with condition in that case, it will never work. I will say it will just run one time, and after the robot will just do an action for one time. Basically, is that. So I said that I would like the front laser. And so I said that if it's over or equal to 0.4, you can run the turn. And I put a rotation of 0.3, and I publish all the time. Because I also noticed that when you don't publish all the time, the real robot will not move. You cannot just send something. You need to publish all the time. And for that, I put it like that. And I would say due to the latency I noticed as well with the real robot, so I put a timer, I would say a timer of 0.5. Like that, I'm sure that the robot move and read at the same time and at the same speed. Otherwise, I noticed that you read quicker. I would say you have the information of the laser in a quicker way than the robot moving. I'm not sure it's clear, but yeah.
No, yeah, it is. It is.
So yeah, for that I did that like that. So I would say I have a timer in my whole program to be sure that the robots can move and have the information afterwards, and not through information when it's moving, basically.
Right.
So when the robot stopped to move, at that moment, I say to it, you stop to rotate when you find something, I will say a wall, and you move to the wall. I put 0.28, it was 0.3, to have, I will say, the robot to be in a good configuration to do the laps afterwards. Otherwise, it was too close to the wall, and regarding the information in terms of speed and angle I put, unfortunately, the robot was hitting the wall quickly. So, it was swinging a bit too much around the line. So for that, I put 0.28. So this is a personal choice regarding, I will say, the different tests I run with the real robots. And I put a linear value of 0.05 to be sure that the speed was correct regarding the information reading by the robot and the speed of rotation as well, to avoid the robot to hit a wall because he was not turning enough quickly due to the speed.
Right. Okay.
So for that. So yeah. And it's the same at the end when you are in front of the wall, you just rotate. So here we say I use the 90-degree angle. So for that is 180 because we're still with a step of 0.5 degree. And I put 0.4. It's the same. It's a personal choice regarding how the robot was turning and was trying to align to the wall, basically.
Right.
So something that I forgot to say. So because it's, I would say it's a server, I use in that case the callback, the callback option you have in ROS, so to try to have I would say the reading of the laser plus the moving at the same time to avoid any collision, to have something all the time doing and blocking the other action, I would say. So for that, I did that like that. So this was for find the wall. So now for I would say this is my main script. So here you can see that I also use, I would say, the callback, but I use material exclusive and not something, and not the reentrance option. I use the reentrance because I want to have everything reading at the same time. But in the other case, I want to block something. I would say I want to block an action. I want to have an action doing and blocking the other before to move, to be sure that everything would be done in the order. And for that, I'm creating different groups.
Okay.
We have a group for the client, so to have the client to be done first. And after we have a group to be done, I will say, between the reading and the wall following. Okay. So I have a publisher subscriber, so I will say to move and to read the laser. And so up here I define my client. So I send the request. So because normally, yeah, you need to send a request to say to your servers that you want something to do, I would say, basically. And I define my action client here as well, but I will come back to that afterwards.
Okay.
And so, yeah, for the motion, so because I did some tests and I have a program of synchronization between my robot and what he was reading, I have a try to see if I stop between two actions to see what was happening. For that, I have that here. But at the end, because I did a timer, it's not, I will say, I don't need it anymore. So what I did here, I did, because I would like the robot to stop after a loop, because it was a condition in the test book. So I decided to have a flag. So the flag normally becomes true. when you complete a loop, when the action server say you complete a loop, basically. So when normally the final condition of the action is complete, to say that normally your current distance and the initial distance are enough close to each other to say that you are the starting point, basically. So normally when that is complete, you go out of the loop and the robot stop. But unfortunately, something happened in that case and it didn't work, but normally it works.
Right, right. No, I see what you did there. Yeah.
Yeah, so for that, I did that like that. But I will come back to that afterwards because it's the logic of the action. And so here what I did basically, so I follow the condition. So I say, I use two lasers in that case. I use the front and the side, so the right side. So the right side to keep, I will say contact, to keep, to detect the wall because the wall is on the right. And front to turn when you need to turn because it's a rectangle basically. Otherwise, you cannot really do that. And so here it's the same. I would say the limit I put depend of the speed you want to use and the rotation speed as well, I would say. So you need to try and to see what is the correct value regarding the simulated robot or the real robot. And it's the same here. I said regarding, I would say what was in the textbooks. If on the right, I'm over 0.3 meters, I move towards the wall. If I'm too close to the wall, I move backwards the wall, basically, away from the wall. And if I'm between 0.2 and 0.3, I carry straight. Basically, is what I did. And it's the same. I have a timer all the time, and I'm publishing all the time like that. And so for the action server, so the action server was a bit trickier, I found, I will say, because you need to read the odometry and you need to publish a feedback. So I will say we had the feedback published in my case. So if the stuff wants, yeah, no, it's here, sorry, it was the wrong one. So here you can see that we can, like we receive and we have a feedback here.
Right, we have a wall follower node and an autumn recorder node, I see.
Yeah, I put both together just to see if I can stop it. I receive, up, stop. If I can scroll up.
Oh, maybe because you got those infinites, you won't be able, but
unfortunately, yeah. But yeah, so I try in my case to have both information to keep track, I would say, of the robot was doing in terms of debug. So to see what the robot was reading, to check if everything was correct according to the following wall, I would say, program in that case. So, and at the same time, I have the feedback. So yeah, so in that case, what I did, so I defined my server, I would say, yeah. And I decided I defined as well, I forgot to show that I defined my different interface, because normally when you speak between a server and a client, you have an interface between. So you send a request. In both cases, it can be a request or a goal. And after you go to the interface and you go to the server and the server gives you what you need, move to the interface and come back to the client, basically. And so I defined them somewhere. And it used to find them again. Anyway. I would say I have one there here. So in my case, for example, for the action, so I defined it like that. So I said nothing for the goal, so it's an empty goal, and I have the result and the feedback here basically. And so I defined in some points, some point objects. To try to store, I will say, the current value of the odometry plus the value of the odometry, and I defined also a list somewhere and the first odometry, because as I said in that case, the condition was you needed to compare, we say, the first reading with the current reading to see if you were at your starting point, basically. So if you complete a lap. So in that case, I decided to have another variable just for the first odometry record, just to be sure to have it. Because the problem of the table, because normally you can use a table, but I noticed that the problem, I was not sure of the index. It was a bit like random reading. So that meant just to be sure that I was reading the correct value, I decided to store it in another value by itself.
Right.
Otherwise, the logic I have behind was I detect if the robot is stop or not. So for that, I have, if I can find it. Record odometry. Yeah, it would not have that because my logic was I detect if the robot is stop or not. If the robot is stop, I don't start to read or to record any odometry value. But when the robot start to move, so it means that I found the wall and everything is done. I'm ready to follow the wall basically. At that moment, I say, okay, so this is. I say this is true now, so I would say this is false now, so I can move. So it means that the robot is not stop anymore. And so I move, and by moving, I will first of all check is the first odometry value, so the variable I call first odom, is equal to 0 or not. So if it's the first reading or not. If it's the first reading, I will collect that value and I will store it in the first odometry value. And at the same time, I will put that in the list to have at the end all the odometry reading
Points.
as it was asking in the test book. And afterwards, if that condition is false, it means that I'm the second reading or more. So the moment I will put that, I will say I will store that in my current reading that is somewhere. And afterwards, I just calculate the distance to return. I will say the current distance as asking as sorry as the feedback. So I calculate it like that with an absolute value,
Right.
basically. Yeah. And afterwards, I compare all the time, I will say. So it's my stop condition. So if the length of my table is higher than 2, so it means that I have 2 values basically in it. I can compare them. And so at the moment I compare them and I put, this was regarding, I will say, the simulation, because I was quite concerned in the simulation. I was quite happy for that, how really something that was swinging a little bit around the line.
Mm-hmm.
But with the real robot, unfortunately, it was working. But today I say these value are not good. So if I modify the value, normally it would be right. So afterwards, I just put I would say an information for I would say for the user saying that we reached the initial position, so the program will stop and the robot will stop. And otherwise, if I have any problem, because I noticed in the simulation, due to the speed I was using for the robot moving, the step between due to two variables, sorry, values was not enough. So at that moment, I decided to put an indication like it's normal that it stop. It's just because it's a very short distance.
Right.
So the difference between A and the first reading is almost the same. So at the moment, something needs to be done here. So it's just like an indication debug, still indication in that case. And otherwise, I say that we're still in the while loop and we carry on. Otherwise, it's the first record if the length of the table is less than 2. And like that, I would say. And so it was I done, and after I have the main, etc. And like that, I would say. It's the logic behind my program.
Right. Okay. All right. Well, very clear. Very clear. Thank you for your explanation. Uh, let, I'm curious. Is the robot still moving?
Now I think it's fortunately,
Oh,
I
it
would
ran
say,
into a wall. All right.
yeah,
Okay.
this is the problem, I would say, due to the swing and the
Right.
communication as well, and different parameters in that case, the robot will move, I would say, step by step towards the wall.
And this is also because the odometry will start drifting more and more. So makes sense that after a long time it would do that.
Yeah.
But congratulations, Claire! Really nice project. Really clear explanation. I have some questions for you.
Yeah,
So do you mind stopping sharing your screen so we can
sure.
take a look at our faces here? All right, cool. Thank you. So yeah, congratulations. I really, I really liked a couple of things that you. First of all, I like that you took the time to consider the changes between the simulation and the real robot. I thought that forces you to look at a real situation and adapt with the things that you did. For example, and you took decisions that I like because they're we had some specifications for you, but you can do whatever works for you. For example, you said that it wasn't when you're trying to find the wall, you weren't trying to find the real minimum value, because like one that's close to it, it's still going to be near to the wall, for example. Like those kind of decisions are nice. And I would recommend you also for
Mhm.
the. So I kept thinking about this the swinging that you talked
Yeah.
about. That I assume you would like it to be more, you know, straight. So it's for the robot to react quicker, right?
Yeah.
So I think I saw a lot of, especially in your main program, your
Mhm.
sleep is of 0.5 seconds
Yeah.
of the whole loop, right? And that means that's 2 hertz. Um,
Yeah.
so every time it's running like that. I would recommend to use to see how it would work, something like this, that I mean a similar logic, instead of with a sleep, because at
Mhm.
that moment you're kind of blind, and for that amount of time your program is basically dead. So you could try using the RCL Pi rate function, and
Okay.
this you make the node spin, let's say at
Okay.
10 hertz, and that means uh, you will get more, more info per loop, and probably uh, react quicker. That would be one
I
thing.
see.
There could be a thousand other things. Then I also recommend you take a look. For this is just 3 cases, right? So
Yeah.
if it's going away, go like that. But you can also define. I would also recommend to look at how to put in a PD controller
Okay.
in Python. It's really simple.
Mhm.
I mean, you look it up and they just give you the the
Describe. Yeah.
class. You put it in, and then you understand. You just do it by the error, right? You define an error that you want to minimize, and
Okay.
that will also probably help with the thing. I know it wasn't required, but for your.
Yeah, no, no, no. Thank you very much for that. It shows that the time dot sleep is a bit. I would say it works, but it's
Right.
not the most appropriate in that case because, as you said, the robot is blind for 0.5 seconds.
Yeah, I use
So
it all the time too. But it's a
yeah,
matter of recognizing when this time, especially when you have more and more nodes. For example, you had
yeah,
3 nodes here. Let's say you had 10, and the sleep on one affects another one, and you got to start keeping track of that once that happens. So maybe uh, uh, use that rate function is really
yeah.
useful.
Thank you very much for that.
And yeah, and then. Um, I really liked, for example, in your Autumn recorder, your action server, that you detect when the robot is moving. Um,
Yeah,
so I thought that was really clever, and it made me think about when when do you call the action server in your main, like you do a main launch, and
yeah,
you're probably calling that action server from the main
yeah.
wall follower. Do you call it right at the beginning?
No, I call it after the client. So I decided to have the server. I recorded the server client, and after the client action.
Right. Okay. So after the server, after if it's found the wall, that's when you call
Yeah,
it. Okay. Okay. Okay.
yeah. I tried to put them in order because I was thinking in somehow due to the callback function I used. At that moment, if I switch, I will have the action starting first and the server starting afterwards. And I was afraid that something happened, in terms of priority.
Oh yeah, and that's how you should do it. That's what I would do too.
Okay.
And on the I'm thinking about also that uh, how why it didn't stop, right? And I
Yeah.
saw the condition that it was like 10 centimeters, right, between the
See,
initial. Yeah. So
it's
that's, I mean, that's a good idea, yes, uh, and it's maybe a little bit overcomplicated. I mean, it's not necessary for
okay.
the robot to finish a lap, but so if you wanted to make sure, you can start like simpler. For example, putting a so you're getting the odometry, right?
Yeah.
You're getting that X value, and at the end you spit it out. So we know we have this. For example, start by kind of noticing how much X distance is traveled, and
Yeah.
just put it hard coded. I know that's terrible, but that's
Yeah.
one
No.
option. And then uh, it makes sense that 10 centimeters it will have a hard time finding it, but that's how it should be. Just add it a little bit more
Yeah.
of
No, no,
logic.
I agreed with you. As I said, it was a condition I put in the simulation, and I don't know why it was working with the real robot. So I would say I was like, "Well, it's fine. Maybe I was just lucky." And I just let it like that when it's sure that I will have a need to change it, I would
Yeah,
say.
yeah. If you put 30 centimeters, it'll do
Yeah,
it. So
it's it for that, I would say. And when I was showing it just this morning before the video, I was like, "Oh, it works. It's fine."
no, that's fine. That's fine. Just that comment. And then other than that, I mean, I thought it was really clear. It obviously looks like you have experience with Python, which is nice because we saw that really nice program, very structured, very nice functions calling other functions how it should be. And yes, congratulations again, Claire. I think
Oh,
that's it for me.
perfect.
It was
Thanks.
really nice project. And uh, to everyone else that's watching, you can do here what Claire did with her course for ROS 2 Basics. This is our final step to offer a certificate. That's how we know, that's how we make sure that people are actually taking something valuable from our courses, which is the main point. So I invite everyone to do what Claire did. And Claire, again, very, very nice job and congratulations.
Thanks.
All right, guys. So that's it for us. I will see you guys next time for our next presentation. Thank you, Claire. Bye bye.
Thanks. Bye.
Okay, we're done.